So now we're going to get some practice with using the fundamental theorem of calculus to calculate areas. And the areas are going to be given by these two integrals here. Okay, let's start with the first one. So the first one says the area between 1 and 5 and between the graph of 3 minus 2t plus 3t squared and the x-axis, right? This should actually be a t. So the first step here is we're going to find an antiderivative for this, right? So we need a big F, right? An antiderivative. And then the integral is going to be given by plugging in that 5 into the antiderivative and then subtracting what we get when we plug in a 1, right? So the fundamental theorem of calculus tells us that this integral is the same as finding an antiderivative and then plugging in 5 and subtracting off what I get when I plug in 1. Okay, so this is actually what we need to do now, right? So first we find the antiderivative and then we're going to plug in these numbers and do the arithmetic. Okay, so let's go ahead and do that, right? Let me get this out of the way. So first find an antiderivative, right? Let me do this in black. So the antiderivative of 3, right? We're going to do this in pieces, like first we're going to do the 3, then the minus 2t, then the 3t squared. Okay? So the antiderivative of 3 should just be 3t. If you think about that, the derivative of 3t should give us 3, right? If I take the derivative of this, the t goes away and I'm just left with the 3, right? So that means the antiderivative of 3 is 3t. Okay? So in general, if you have a constant and you're finding its antiderivative, you're just sticking a t on there, right? Or an x or whatever variable you're using. Okay, so now antiderivative for minus 2t. So for that, we're going to use this power rule that we have for integrals. I'm going to write the minus 2, right? It's a constant. It's just going to hang out there. So the antiderivative of t, I'm going to add 1 to the power. Okay, so that gives me a 2 power. And then divide by the new power. Okay, so that's the rule for antiderivatives. So you add 1 to the power, divide by the new power, right? And that's when you have something like x to the n, where n is some number other than minus 1, right? And we're going to see that come up in the next integral. Okay, so here we do it again. So this plus 3 is going to hang out. I've got a t squared, so I'm going to add 1 to the power and divide by the new power. Okay, and then we can see there's going to be some cancellation. These 2's go away, these 3's go away. And so I'm going to evaluate this, and this is the notation we use. This big bar and then a 5 on top and 1 on bottom. This tells me that I'm going to plug in the 5, and maybe I'll use different colors here. So I'm going to plug the 5 into this antiderivative we just found in here. So actually, let me first simplify that antiderivative, right? It'll make things a little bit easier. So let's simplify that antiderivative. So this is 3t minus t squared plus 3, not 3, but t to the third. Right, so that'll make it a little bit cleaner when we plug in the numbers. So this is equal to, now let's plug in those numbers. So we've got 3 times 5 minus 5 squared plus 5 to the third. Okay, and then minus what we get when we plug in the 1. So that'll be 3 times 1 minus 1 squared plus 1 cubed. Okay, so this part that you're seeing here, this expression right here, is precisely the expression that we were thinking about before. It's the f of 5 minus capital F of 1, right? That's what this whole term is here, okay? So then if we do the arithmetic on here, so let's go ahead and do it. So this is the same as 15 minus 25 minus 125, and then minus 3, and the minus 1 squared and the plus 1 cubed are going to cancel. Okay, so you do the arithmetic on here, you should get 1, 1, 2. Okay, so that's telling me that the area beneath this graph, or between this graph and the x-axis, and between x equals 1, or in this case t equals 1 and t equals 5, that area should be 1, 1, 2. We can actually check that with Desmos. So if we go ahead and get into Desmos here. So here you can see in red the graph of the parabola. And then in blue here is the shaded area that we're looking for, right? So from x equals 1 to 5, beneath the graph of the parabola and above the x-axis. So this blue area is the one we're looking for. And you can see on the left there, the integral from 1 to 5 of f of t dt. and you can see that that's equal to 112, right? So that's the number that we found using the fundamental theorem of calculus. Okay, so let's look at the next one, right? So the next example, so that's this integral right here. Maybe let's go on to the next page. So that was the integral from 1 to 4 of 2 plus u squared over u to the third du. So here it'll help us to just do a little bit of simplifying first. So let's go ahead and distribute this u to the third into the 2 and into the u squared. Right, so this is the same as 2 over u to the third plus u squared over u to the third du. And I'm going to go ahead and write these as powers. So just like when you're taking derivatives, it's a little easier when they're in terms of powers rather than being in the bottom of a denominator like this. So this is 2u to the minus 3. And then I'm going to get a cancellation of a u squared from top and the bottom. So I'm really just going to be left with 1 over u. So if we maybe think about this term in here, this is the same as 1 over u. And so I'm going to write it here as u to the minus 1. Okay. So now finding the antiderivative, right? So we're going to find an antiderivative. For the first part, we're going to do that same rule that we were using before. So 2, and then add 1 to the power. That gives me minus 2. And divide by the new power. So the new power is that minus 2. And here's that one occasion where we can't use this power rule, right? So if you think about it, if you add 1 to the power, so if you add 1 to minus 1, you get 0. And then you have to divide by the new power, right? But the new power is a 0, so you can't be dividing by 0. So this is the one occasion where you can't use that power rule. But if you think about it, this is the same as 1 over u. And we just talked about in the previous video what the antiderivative of something like 1 over x looks like, right? In this case, it just happens to be a u, 1 over u. And the antiderivative, according to that video, was ln, absolute value of u. And we'll write our notation here that says we're evaluating at 4, subtracting what we get when we evaluate at 1. Okay, so let's go ahead and do a little bit of simplifying because these 2's are going to cancel here. So this is the same as, and I'm going to write this as minus, because I've got a minus right here, minus 1 over u to the second, right? So I went ahead and wrote this in the denominator, and then plus ln of u, not a lot to simplify there. Okay, evaluated from 4 minus 1. So this is the same as, so I'm going to plug in the 4, right? So minus 1 over 4 squared plus ln of 4. And then minus what I get when I plug in the 1. So it's going to be minus 1 over 1 squared plus ln of 1. Okay, so again, this is the part of the fundamental theorem of calculus that says plug in the upper limit, subtract off what you get when you plug in the lower limit, right? That's exactly what's going on in here. Okay, so if we do the computation here, so this is the same as minus, so I actually won't write parentheses, so minus 1 over 16 plus ln of 4 minus, so this term right here is a 0, right? This is a 0, ln of 1 is 0, and this is a minus 1, so minus a minus 1, that's going to give me a plus 1. Okay? So now if I take this, punch it into a calculator, you can see I kind of did it already, so this is the same as 2.3237, and then there's a bit more. Okay, so it's approximately this. So now let's check back with Desmos, right? So if we look back at Desmos and see what they got there. So let's hide the other graphs and let's put the graph that we're looking at here. So you can see this time we've got a sort of hyperbola, and we're looking, remember, at the area between 1 and 5, right? So it's going to be, or not 1 and 5, 1 and 4. So that's this little chunk of area here. And you can see down at the bottom on the left here, we've got integral 1 to 4 of g of x dx. G of x is the function we're using, and then you can see that's equal to 2.3237 blah blah blah, and that's precisely